So in this session on signals and system, we are going to study one more example of calculation of convolution. So let us start. So in this problem, we are given two functions xt and yt. Both are rectangular pulses. Both of them have a height of 1. However, xt lasts for a period which is starting from -2 seconds to +2 seconds, whereas yt goes from -1 to +1. That is the difference. And what is the problem? Problem is to obtain the convolution between xt and yt and plot it, call it zt, and then plot it as a function of time. All right. So let us go through our steps. Remember, the first step is change t to tau. Okay, tau is our dummy variable. So when you do that, t becomes tau. So our x-axis is now calibrated in terms of tau for both these functions. Next, what we have to do is to invert one of the functions and then delay that function. So let us choose y tau for inverting and delaying. It doesn't matter which one you choose, but we have to choose something. Let us choose y tau. Now notice that this y tau is an even function of tau. So for positive values of tau, it is same as for negative values of tau. So even if you invert this, time invert this, rotate this through 180 degrees around the y-axis, you will still get the same result. So y tau will be equal to y of minus tau. That is same. But now you delay this by t seconds, so it will shift to the right. So this is shifted to the right. So what was a 0 point of y tau now becomes t, and the right hand side becomes t plus 1, and the left hand point is t minus 1. Okay. Now next what we have to do? We have to slide this function. That means go on changing the value of t. So we'll slide this first, make t sufficiently negative so that this function slides to the left and there is no overlap. If there is no overlap, then clearly the product of x tau and the shifted function will always be 0 and there will be no convolution. Once we have done that, then we slide this function to the right. When there is overlap, calculate the product, integrate it, and you will get the expression for the convolution. However, the product expression does not remain constant over all the ranges for t. So by graphical inspection, generally you will be able to find what are the ranges of time for which the expressions are different. So when signals are as simple as this, it is easy to do it by inspection. But when they are more complicated, you will require some kind of a rule, a mechanical procedure by which to find these ranges. So that we shall do in a later session. But right now note that when t lies between -3 and -1, you will get one expression. When it lies between -1 and +1, you will get another expression. And when it lies between 1 and 3, you will get another expression. Okay. So let us first slide this to the left. Note that when t is equal to -3, these are just touching. So if I now make t more negative, clearly there will be no overlap and convolution will be 0. So now what you do is you start sliding to the right. And you slide it so that t lies between -3 and -1, somewhere, doesn't matter where, but it lies between -3 and -1. In that case, we have shifted it to the right. So t is now clearly lying between -3 and -1. And now clearly there is an overlap. So in order to show the overlap clearly, we plot both the graphs on the same axis and we'll get this. So this is my yt minus tau, and you can now see that there is an overlap. Note that yt minus tau is drawn with red color and x tau is drawn with a blue color. And clearly the shaded section is the overlapping section. So we need to integrate from tau equal to minus tau to tau equal to t plus 1. Note that these values are the values on the x-axis of the graph corresponding to x tau, whereas the center point of yt minus tau is t and its right hand side is t plus 1. this is t minus 1. So notice that in this overlap, the right hand side corresponds to yt minus tau and the left hand side corresponds to x tau. So clearly your limits are from minus 2 to t plus 1. So now what about the product? Now note that during this time, during the overlap, x tau has a value of 1 and yt minus tau also has a value of 1. So the product expression is 1 into 1, which is simply 1, and that will be multiplied by the width. So you just have to calculate the width by subtracting minus 2 from t plus 1. So you will get your expression. So let us repeat that. When t is between minus 3 and minus 1, the area under the product, which is the integral, is given by area equal to height into width. So that is 1 into 1, t plus 1 minus minus 2. So that will be t plus 3. So when t lies between minus 3 and minus 1, the expression for the convolution is given by t plus 3, which is a straight line with a positive slope and a particular intercept. Okay, let us now shift this yt minus tau further to the right, and let us shift it so that t lies between minus 1 and plus 1. In that case, you can see that this complete area for the yt minus tau, note that blue one is x tau and the red one is yt minus tau. So this complete area is also the area of the overlap. Again, as far as the product is concerned, it is 1 into 1, but the width now is t plus 1, that is this point, minus t minus 1. So let us do this calculation. When t is between minus 1 and plus 1, the area there is a full overlap. So 1 into 1, t plus 1 minus t, and this is minus 1, so it becomes plus 1. T cancels, you get 2, which means that as long as t lies between minus 1 and plus 1, the area remains constant at 2. Finally, let us see what happens when t lies between 1 and 3. Then we will find that the convolution is again a straight line but with a negative slope. Let us see that. So in this case now, this is the overlapped portion. Okay, for others the convolution is 0. Now this point is 2, remember, is the blue line corresponding to x tau, and this is t minus 1. This is corresponding to the red line corresponding to yt minus tau. So in that case, your area will be 1 into 1 as usual, that is the product multiplied by the width. So that is 2 minus t minus 1, so 2 minus t plus 1, so that gives you 3 minus t. And this is as long as t is lying between 1 and 3. As soon as t goes beyond 3, again there will not be any overlap and you will get a 0 result. So if you plot the convolution as a function of time, this is what you will get. Between minus 3 and minus 1, you get an equation for straight line, that is t plus 3. Between minus 1 and plus 1, you get 2. And between 1 and 3, you get minus t plus 3. Note that intercept here is 3 and the slope is negative. Here the slope is positive and the intercept is minus 3. Alright. So this is one example of how to solve for the convolution. Now there is one important check that you can do after performing the convolution. One check you can do is, start time of the convolution is the sum of the start times of two signals. That is one thing you can check. And end time of the convolution is sum of end times of the two signals. For example, in this case, the start time of xt is minus 2 and the start time of yt is minus 1. So minus 2 plus minus 1 is minus 3. That is the start time of the convolution. And the end time of the convolution is the sum of the end times. So end time for xt is 2 and end time for yt is 1. So 2 plus 1, 3. So you expect the convolution to lie between minus 3 and plus 3. And indeed that is so, as we have verified. So we have seen one more example of calculation of convolution. In the next session, we shall study how to write the program for finding out the convolution and plotting it. And further to that, we will see the mechanical rule by which it will be easy for us to find the ranges of time for which the expressions of the product change and how to find the limits of the integration. That is for later sessions, but right now that's all.